diffusion now. We come. Okay. I'm sorry. Comment has not been streamed. It is okay. So the rate of diffusion, which nilisema we call it rate. So the other time we were saying it is rate. Now I'm introducing something else, which is we are saying now capital R. So nilikuwa nimesema we'll check both of them, we'll check both of them but you choose the one that you find yenye inakufit, which is better for you. Now, so the rate of diffusion is, I want you to see inverse. When you talk about inversely proportional, let me just mention this one. We were talking about the Charles and the Boys law. Now, one of them was inverse, the other one is direct. Now, it is very important to remember that one. I think we'll go to a revision after this, and then you see what we're talking about. So, when I talk about inverse, I introduce the one over what I have been given. Then I introduce to 1 over something. It is just 1 over something. So I introduce 1 over something. I hope you're okay. You introduce 1 for inverse. When it is directly proportional, if it was the rate is directly proportional, I would have said rate is directly proportional to square root of density. That one is directly proportional. But because this one is inverse, we change that one. So this one, let it not even confuse you. So this one is wrong from Graham's law. So this one now is, let me wrap these ones. I don't think we need these ones anymore. So that we continue. So whatever I was explaining, when we are changing the mass and the rest, easier. It's just like saying the higher the density, the higher the molar mass. And the vice versa is true. So that means if something is heavier, it will move at a lower rate. So, but let us continue. So this one is density, is inversely proportional to the density, which is also the rate of diffusion is inversely proportional to the what? It's the mass. Because tumesema mass and density, they are sisters. Let me just say they are relatives. They are relatives. Let me not say sisters because of gender biasness. So they are relatives. So density na mass, they are relatives. Ukiongeza mwingine anakuwa affected directly. That is direct proportions. If you increase the density, you must increase the mass. Or if you increase the mass, you must increase what? The density. That one. So if you are to do now, so this one I think was simpler. When I saw these dots, I thought maybe you can do this one so that people can see. So we will solve it the same way we did that one. Hata kama haijaonyeshwa hapa. So we said hapa because we say R, when you introduce the equal sign, you introduce the constant, which is K, over the square root of density. Let me not write in full. Let me write D for density, which is also equal to K over the square root of RMM. RMM. Now, this one tumepitia shortcut. This one is actually, you just keeping it directly. So if you make K the subject of the formula, I want you to make K the subject of the formula so that you see. So in unapata R, and then you multiply by, let me just put a multiply by the square root of the density is equal to K, which is our constant. Now, I still repeat, K is the constant. So don't forget that one. Now, if we have two gases, for example, A and B, all of them, so it will be RA multiplied by the square root, let me just put directly instead, B, density of gas A, I'll just do for the density, for RMM we just replace it because they are directly proportional, is equal to K. Another gas B, I want to explain this one, how this one is coming to be. We'll have another gas B where we'll have RB, so the rate of diffusion of gas B, you multiply by the square root of that, the density of that gas B is also equal to what? A constant. So you constant EK, so this K and this one, are the same. We can say RA square root of DB. So I'll wrap that one. Or I don't know where I'll write. Let me write on top here. I hope you are following so that you don't get lost. Or let me just continue. So we have RA. Sorry. So we have RA square root of DA. Sorry. So square root of density of A is equal to RB square root of density of B. Na hizi vitu zote zimeandika RA square root of DA is equal to RB square root of DB. Hii yote is equal to a constant figure. Is equal to a constant figure. Now, so for this one to make sense, we normally in mathematics we say we bring the like terms to one side. So tunaleta like terms. For example, the rate and rates, we know they are like terms. So what I can do, I can divide this one over over RB, alafu hapa over RB. So we are just doing what we did, but now better because we're using capital. The other time, the notes were in small letters. So you cancel that one out. And then I divide here also over square root of DA. And then I divide the other side over the square root of DA. So what I'm doing is I'm bringing the factors together. Those ones we call similar variables. I'm making them similar variables. So we have density and density. We have rates and rates. So we want them so that it becomes easy when you're solving. So you'll find that the DA and the DA go. Whatever remains now is this one. Whatever remains RA over RB. Yeah, this one. So it is RA over RB is equivalent to the density of B, which is here. Density of B, ndo hii. I'll circle where we are. I want you to follow the notes and what I've written. And then you have the density of A, which is here. This one is how this one is coming to be. I was just explaining that. So I just wanted people to understand how that one has come to be. So actually, if you forgot the formula, ukisahau formula kwa exam room, you don't have to be worried. You can come up with the formula by yourself. Using what? Using the law itself, which is the Graham's law of diffusion. So unaweza kuja. And because now the density is directly proportional to the molar mass, I just replace where there is density, I put RAM of that particular gas. For example, RA remains RA, RB remains RB. So instead of density of B, I put what? RMM of B. And then instead of density of A, naweka RMM of A because they are directly proportional. So this one is number one. Equation is number one. This one is equation number two, which they are very similar, but it can bring confusion. So remember the density. Remember, density and mass are working together. So zinatembea pamoja. So they're working together. So there's no way you can separate where there is mass. Of course, remember we were talking about matter. I want you to recall the previous lesson we said it is matter. And matter is anything that has mass and occupies space. When we talk about space, anything that occupies space, we are talking about it's something that has volume. Actually, when we say occupying space, if you cannot occupy space, that means you do not have any volume. So when you talk about occupying space, you're talking about volume. So, and if you have mass and volume, you can get the density. Now, I want you to see now what happens here. Remember, the rate of diffusion was inversely proportional. Time now is directly proportional. We are changing. We are saying time is directly proportional to what? Density. Because if you are heavier, now let me just say, if you are heavier, it will take a longer time. If you are heavier, it will take a longer time to Let us just use an example. Literal example. Kukimbia, if you have an AV person, or let us not use, let us not victimize people. Let us use an elephant because we know already it is AV. So you have an elephant, and then you have a what? Let us use a hare or a rabbit. Let us use rabbit is domesticated, or hare, which is, and they are moving. Which one will move faster? Yeah, which one will take a longer time to cross a field? The heavier one. Yeah, so that is why we're saying, and remember, density and mass, the relatives, zinaenda pamoja. So let me wrap that one first, and then we continue, and then you see. So I thought this one would be easier because it is a little bit summarized, and you already had an idea. Took on an idea previously. So because you had an idea, we say now time is directly proportional to the density or the molar mass, because all of them were relatives. They were directly proportional to each other. So we are introducing another proportionality, but direct, which is time. And this time we are saying it is directly proportional to the density. It is not the rate. Now, the other time tuliongea nilisema anytime you see the rate, wewe jua tunaongelea nini? Time. So anyway, so TA, so instead of TA over TB, and then we have the density. I want you to see this one. E ilikuwa inakuja hivi, but this one they are moving directly. Yeah, na hii directly. So when you talk about time, the B comes down for both of them. When you talk about rates, we are talking about A and intercrossing. You can intercross them. Let me use the word intercrossing. I hope it is correct. English term. I hope it is correct. But when you talk about time, we are saying TA. So this one is number 3, which you are supposed to know. And this one is number 4 in terms of math. But I want you to see B, B, A, A. This one is A, chini, A. The other one is B chini, B juu for density. Those ones are very important. Those ones are the 4 equations that we are going to use today. And we'll do an example for each so that people can understand what you're talking about. Sijui kama tuko sawa. I want somebody to say something. Or you can do it on the chat. If I'm moving too fast, you say something. Yeah, we are very few. I think we are around only 2. So, are you understanding something? I knew everybody who was in. I thought I saw O. Did I see O? Yeah, and Daniel. Can somebody say something between the two of you? If you can. If you can't, then you can do it on the chat. Because I thought somebody had. So, kama tumeelewa, we continue. Those I want to do an example. So, those ones are very, very important.
We are following
Yes,
up.
yes. Sorry? Daniel?
Yeah, we are following up. Nilikuwa busy kidogo. Nasema nilikuwa
Yes.
nimeshikika kidogo but nafuatilia tu kiasi, yes. Toka class.
There's no problem. But yeah, as long as you're understanding, I don't have a problem. Now, so those are the major Graham's law of diffusion equations, the 4 of them. Which the most essential part, like I said, is to understand how these ones are. Na nimesema kwa rate and density you interchange. Interchanging, I'm saying RA na inakuja opposite direction, B opposite direction. But when you have the time and density zinaenda the same direction. Let us do an example. So carbon dioxide has a molar mass. So these ones they have done for you. They have calculated the molar mass for you. But I'll give you a question that they have not calculated the molar mass. The molar mass. So we are saying carbon dioxide gas, which now I will calculate the molar mass. It is very interesting. Molar mass, you add these ones. So I'll give you, I'll tell you how it is done. I think we'll do an example. Let me just touch on that one now. And nitrogen has a molar mass of 28, so we have N2. When you're given the name, that is why I was saying it is very important for us to know how to write the chemical formula of whatever you're given. So you can be given sulfur peroxide, you're supposed to know how to write the chemical formula. sulfur 6, you could be given anything. You can even be given the ozone layer, yeah, because it is a gaseous material, or it is gases coming together. So it is very important for you to know how to write the chemical formula. And the chemical formula is done in form, I think it is in form 2, the first topic of form 1, but I think form 1 we normally touch mostly about the word. So anyway, so carbon dioxide gas has a molar mass of 44, nitrogen has a molar mass of 28. So nitrogen is lighter, or we say it is less denser than carbon dioxide. So because it is lighter, automatically the rate of diffusion of nitrogen is higher than that one of CO2 because of the weight now issue. And when you talk about the weight issues, that is the mass. Of course, mass and weight, they are relative. I hope you know how to convert it, but for now, we are not talking about that one. So mass, remember when you talk about mass and density, like I mentioned, they are relatives. They are relatives. That one is very important. This one is just an example that you are being told about. Now, maneno density and how they diffuse. So the reason nimesema, so hapa wamesema nitrogen is lighter, which is less dense. Same lighter, when you talk about lighter, we're talking about less dense than carbon dioxide. So because it is lighter, nitrogen will diffuse at a higher rate than CO or carbon dioxide. That one is very important. Now, this one is just an example of what? Because you have to do a calculation. So ammonia has a molar mass of 17 grams. Nitrogen has a molar mass. The reason why I introduced this one, I'll be sharing another book for examples. So there's no problem. If you see me nimeshare ingine, you don't say kwani imekuwa aje. Yeah? So ammonia has a molar mass of 17. Nitrogen has a molar mass of 28. So that one now, somebody even can ask you. Somebody can ask you. This one is an experiment that we did I explained the other day about these experiments, and it is being repeated here. And we had a different the other time to the na tukaona. So we say nitrogen is thus, because it is, you can see now, nitrogen is the ammonia. Let me just use the ammonia. So ammonia is less dense because it, or we can say, is lighter than nitrogen. I want you to see nitrogen is that twice. So when you are twice, let us just leave it let us just not use English. So ammonia will diffuse faster or at a higher rate than nitrogen. And this one we normally show this one now, a very good experiment. And that is done almost 3 times or 4 times in high school level. That is from Form 1 to Form 4 in the 844 system, because you have the CBE also. So in the 844, I'm not very quite familiar with the CBE yet, but we're working on it because I have chemistry students in that who are in grade, is it grade 10? Yeah, who are in that class. So that means I'll have to tutaongea tu mingle, and then they tell me, and then I'll see also the books, they are different, but also but I know this one will be there. So this one is an experiment that we normally use mostly to test that one. Now we have not done practice, so we remember the white cloud or the white ring. We have a stopper containing HCl and a stopper containing ammonia solution. Alafu tukasema a cotton wool, sorry. So tukasema in a diffuse, this one diffuse faster. It is normally shown. So this one, it could be, let me just use the length. If this one is 20 centimeters, for example, distance of movement, this one will be maybe 8 because it is, so this one will be 8 centimeters. So this one, the ammonia, because it is lighter, which has a molar mass of 17, one is 17 grams. Na hii sasa ni HCl, which is 1 plus 35, so you find this one is 36 36.5 or 30, yeah, grams. So because it is heavier, you'll see it will diffuse slower or at a slower rate than the other one. So that one is very important piece to know. So actually this one will guide you in maneno ya masses, that is relative or molecular mass and the density. Where we are talking about the directed proportionality. Yeah. So iko sawa. So let us now go to a worked example. Yani tufanye example. And then I'll give you, I don't know if anybody, I don't know if you are available to do a question. I don't know if you are, if it is okay, if you could, I don't know, you will tell me. If you can do the question, it will be really nice so that I know if you have understood, so that I can go to the other book, which I don't know, it is wider. But so this one is the example that was given. So it takes 30 seconds for, now, this one you can calculate the rate when you're given something like that. So I will talk about that one so that I'll show you. So the question goes this way. It takes about 30 seconds for 100 centimeters cube of carbon dioxide. There are two methods we could solve this one. I will check the one that has been solved. If both of them are missing, we talk about that one. So it takes 30 seconds for 100 centimeters cube of carbon dioxide to diffuse across a porous plate or a porous pot. Any, there's no problem. How long will it take 150 centimeters of nitrogen? For example, remember they have given you now the names of the gases. They have not given you the masses of the gas or the RMMs. So it is very important to remember that one. So to diffuse across the same, so they're saying across the same plate under the same conditions. So we are keeping everything conditions, and when the same conditions in affecting the V2, we are talking about those ones, and those are the factors that were affecting the Charles and the Bozo differently when you switch them. Yeah. So those ones are very important. Now, so they have given you C to be 12. So I have to now have, so I'll move down before I, so you have given you C to be 12, N to be 14, and the oxygen to be 16. So like I said, it is very important for you to know how to write the chemical formulas of these gases so that you can solve them. Sasa kikiwa tujapewa RMMs, you are supposed to know carbon dioxide is written as CO2. Now, nitrogen dioxide, it is NO. I think this one we talk about it a lot in, so to get the RMMs, we'll talk about this one when we're talking about carbon and its compounds for carbon dioxide, and then nitrogen and its oxides, nitrogen and its oxide for nitrogen dioxide, which is in form 3. Carbon and its compounds is in form form 2. Nitrogen and its oxides is in form 3. So I think we have more in form 3. We have sulfur and its compounds, and then we have chlorine and its compounds. So we'll talk about that one. So it must be there. So how you normally get the RMMs? So RMMs, let me just do for carbon dioxide so that we can continue with the question. So how you get the RMMs? You add the individual masses. For example, hapa tuko na carbon na carbon mass yake tumepewa ni ngapi? 12. So una add, so ni 12 plus how many oxygens have reacted? It is O2. So it is 2. So you write 16, that is for 1. And then we add another one, which is 16 for another one. Those people who normally do better, they normally say it is 16. Other people will say it is 16, but 2 times. So times, how many times 16? 2 times. From being guided now by writing the formula. Ukiandika carbon dioxide hivi, you cannot know the masses, the individual masses. And the answer here is 32 plus that one is 44. So that is how we solve. This one is how we solve. Sorry, that one is how we solve or how we get the masses, the relative molecular masses. Now let us continue. So I wanted only people to know how we can. So it is very, very important. Very, very important. I'm repeating that one. Normally tell students. Let me just tell you also, because now I think you're my student. It is very important for you to know how to write the chemical formula rather than the word formula or the word itself, the English words. It is better. I'm saying it is better. Somebody mwenye anajua kuandika the chemical formulas of most of the things in chem have an advantage over the student who knows how to write in English, which is carbon dioxide, which is the English term itself. But if you know the chemical part of it, now you have a better chance of even solving this one or even writing equations. So we continue. So this one for equal volumes, they so when if you decide now, that is why I'm saying we have two methods. So it is good they have given us the two methods, which is nice. I love this one. So it is nice. So if you must be using the formula of time, which is this one now, if you use the formula for time, tafadhali mark this one, very important. If you choose to use this formula, these two ya time, there is a condition. And the condition must be the volume must be equal. That is the condition. Remember, what we have been given is different. They have given us 100 and 150. So if we want to solve that one, we can just say, we use now the relationship here. If 100 centimeters of CO2 takes 30 seconds, what about 150? It will take how many? Yeah. So you don't change for this side because we don't have its rate. Yeah. So you change the side that has rate or you have been given what? The time. Nimesema rate. Every time we talk about rate, we're talking about time. So what 150 centimeters of CO2 takes? So we normally, you can, if you don't have time to write, you can use an angle, the arrow. Unasema 100 arrow inachukua 30 seconds. 150 itachukua ngapi? And then you calculate. So you'll find your time. After getting that one now, you use now. So because we do not have the densities of those gases, we don't have the densities. So we assume that this one now, that we don't use that one. We use the one in parallel. Now, how to calculate the molar mass, I've shown you. So tulipata yake ya hii ni 44. So for nitrogen peroxide also, there's no problem. We can do it. So it is NO2. So unaona nitrogen ni ngapi? You see, it is mass of nitrogen is 14. So it is 14. And then you add how many? Oxygen, there are 16. And the mass of one oxygen is 16. So it is 16 plus another 16. And that is how they got 32 plus, that is how they got these 46. Now, so the time for CO2, I want you to see now what we are talking about. TA, let me put that one. Alafu CO2 pia iko nini? A. For time, we put it directly. B na B. So you put that one. So let me wrap those ones so that we continue, so that we can solve it. You know, now this one is skipping some of the processes, which I want us to know. I want us to know all the processes. So the conditions for using time is equal volume. That is the condition. But if we are going to use another method, which you will see, there's another, that is method one. Even if it is not there, the method two, netafanya bad. I must show you how it is done. Now, so we have TA, which is CO2. And so we now put it. So we have the time for carbon dioxide, which was 45 seconds. So 45 over time for nitrogen peroxide is equal to, I want to remove that one first. I'll remove this square first so that I show you. So it is 45 over time for nitrogen peroxide. Sorry, nitrogen peroxide is equivalent to the square root of the mass of the one that has 45 is CO2, so inakuwa 44. I want to do this. Let me just put it all of it to the square root of 46. Now, how the square came to be is you want to remove the square root. So what I do is I square this side, na square huku, and I square this side so that I remove. So E inachukua hiyo. That is, it is removing the square root. So I'll have 44. So I'll have 45 square. I think 45 squared is 2025. So it is 2025 over T squared. T of nitrogen. So time of nitrogen 4 inakuwa nini? Inakuwa squared is equivalent to 44 over 46. So I wanted only to show that one, but it will continue now the same. You cross multiply. You bring huyu now wanakuwa multiply, and then you bring this one also. That one is very important. And it is very important for us to show. Now, this one is a summarized one, but it is very important. I normally request students to please show. Please onyesha, please show your method correctly. Yani formula. Fuata tu pole pole. Processes. Let me use the word processes. Yeah, just show us. How do you get that one? Yeah, that way, as you move downward until you get the answer. So we continue. sorry. So after you have done that one, you cross multiply. That is what I mentioned. You cross multiply. Okay, cross multiply. Remember, I want you to don't forget that the other one is square. So to remove square again, to remove that square. Let me just show you how the square is removed, so that people. But I think this one you have been told in mathematics, so there's no problem. So na square root E and square root division, and then you now feed the calculator. So this square, so you are remaining with only time, but it is not squared, and the time is for NO2 square root of the answer after now doing the subdivision, get 46 seconds. Now I want you to see this one is 150. This one is the time taken for 150 centimeters cube of nitrogen peroxide, na hii ni time inachukuliwa na 150, not 100. 150 centimeters of, but the difference is very small. 150 centimeters cube CO2. Na hii ni ya nitrogen peroxide. Hii ni ya nitrogen peroxide. So the reason I'm stressing on this one, on repeating this one, is so that you see that the volume must be what? Must be the same. If the volume is not the same, you don't use that formula. There's another formula that you use now, which we'll talk about the rate. So if we get the rates, I want us to do that formula. Actually, they have not done it. Now I'm feeling very sad that they didn't do it in this one, but I will do it. I want to do that formula so that you choose the one that you can use. Now let me wrap this one. So you have gotten the answer to be 35. 46, sorry. But I will request that you help me with this one. But I will do it. Let us see. So we have method 1. That one is method 1. We have another method now, which is called the rate. Let us talk about now. Yeah, rate. So let me just do this way, and we say now method M2. Let me just put it as M2 to mean method 2. I hope you're okay. If you have a problem and you cannot speak, or you don't want to interfere, you can put it on the chat. Yeah, there's no problem. I'll just check it. I'll check the chat. I always do check the chat. So occasionally I do check the chat. So please. So method 2 is the one that we have rate. So we have RA. Let me not use RA. Let me use rate of CO2. And then we have rate NO2. NO2 is equal, because you do not have the density. So tunawachana the density. Now weka to square root of now RMM. So instead of now, remember ile ingine ilikuwa RMM ilikuwa direct hivi AA. So this one now it is RMM NO2 over RMM. Please pay attention to this one also. I wanted the reason why I normally choose this example as number one is because it guides us in both the formulas. Yani inachukua formula zote mbili, which is normally, I think it is better. Now, the rate, we normally divide the rate. Now, for example, the rate of something, rate CO2, for example, is equivalent to the volume, that volume, over the time taken. For that volume, that one is actually the rate, over the time taken. So we have been given the time taken, and we have the volume. So you just have to replace it. So hapa unaweka volume ni 100. And make sure you maintain the units. It is very important for you to maintain the units. I've been repeating that one always so that it can help you up on belly centimeters. I hope you can see cube over 30 seconds. So this one and this one goes. So we'll have 10 divided by 3. I think that one is easy. You don't even have to use a calculator. 3.3 recurring 3. Now, the use of the units is this centimeters cube per second. Centimeters cube per second. Let us watch. Please be very keen. Now I'm canceling this one first and then I proceed because I want to get more space. So let me remove. Yeah, there's no problem. Can I rub? Let me rub for the sake of, but I will continue from the rate of CO2 because I don't have. If I change to the whiteboard, I'll have to move out of this one again. So there's no problem. Let me just rub and then I continue. So please remember we have the rate. So we are choosing the formula which is different. So we continue. We have rate of CO2 now. Rate CO2 is equal to 3.3. Sorry, a recurring 3 means, but it is in centimeters cube per second. So we have the RMMs already. So tulikuwa tumepewa RMMs. So we have 44 for CO2 and 46. So I just replace now using my formula. My formula was rate CO2. Let me write rate C over rate N so that I keep time. I don't waste a lot of time. Is equal to square root, which is equal to square root of RMM. So I'm using method 2. There's no problem. RMM now of N over RMM CO2, which is I'm saying nimetoa instead of writing CO2 which is taking a long time, sema N. So tunaweka rates tuko na ya huyu, which you have 3.3. And I normally advise we write in 3 decimal places. I think it is 4 decimal places, which I think is better. Wacha nitumie 3 for the sake of time, over the rate of N is equal to, remember the units, don't forget the units. I didn't write the units, but ndio hizi ndio hiyo units. So it is very important for you to not forget. Please do not forget the units. Now, square root of, is it 44? Nitrogen is 46, yeah, not 44. So we are changing those ones, 46 over 44. There are very many methods of doing this one. You can divide and then you square root, or you can square. So you can square this side, do ito hiyo, or you can do the square root, yeah, division ya hiyo. So if you do that, you'll find that it is changing. Now, I don't have a calculator. So instead of me doing that, I'm going to choose the easiest method, which I'll use the calculator from the phone. because we want to solve this one. So I'll change the method and then I use this one where, so let me rub this one first of all. Yes. So I write this one now. 3 is equivalent. So I will use the one that I'm dividing those things and then I square root. So I say 46 divided by 44. You can be doing with me, which is now you get 3. So I'm going to truncate that thing because of time. 3.3 over rate of nitrogen peroxide is equal to the square root of, that is the square root of, I've divided what is inside the square root. Unapata na 1. So mine is giving me 1.045, a repetition of 0.45, 1.045. And then what I do next, I square root now. Let me check if I have my scientific calculator. Sorry. Scientific, huh? Now we are used to using square root. Answer, that is 1.45. If you are doing it, if you are doing it also, you can help me. 1.045. So the square root of that one is 1.022. I don't know. I'll just truncate it. So you'll have 3.3 over Rn. So this one is another method, but I want you to choose the one that you are comfortable with. Is equal to 1. Let me confirm so that I don't be giving values that so it is 1.02. 1.02. So nimekata, it is 0.222 something. Now this one, remember this thing is out of 1 over 1. And then you cross multiply. If naive. Yeah, I want you to see how it is done. This one is a different method. It is longer. If you use the first one, it is very important that if you choose the first one, ukumbuke A na A iko juu. And if you choose the second one, you are bringing now the A down and then the B goes up. So we cross multiply, you will find 3.3. And then you divide by 1.0 something. 1.02 is equivalent to rate of nitrogen. That one is rate. I want to be very careful. Hiyo ni rate. It is not. So let me just do it because of time. I must do it also. So it is 3.3 divided by 1. It is a very negligible value. It doesn't affect that 3.3 a lot. Huh? So the rate is 3.2. Let me just do 2.3 or 2.4. Eh? Is it 2.4? Yeah. 2.4 is centimeters. I want you to remember now we have centimeters cube per second. Iko sawa mpaka hapo? No. After you are done with that one, so we go now to dividing. Remember how we got rate. Nataka ukumbuka venye tulifanya rate. So how we got our rate is, remember rate is normally, now remember we have cut a lot of things. So ukitumia calculator like 3.33, this one is 0. So remember rate of nitrogen now is equivalent to, I don't know if you can you see this side? Is it visible? First of all, before you continue. I don't, this one is a calculation. It is visible, or can I change the color?
We can see, mwalimu.
Okay, let me just use a bright one because of that. So rate of nitrogen, this one was rate. So here ionekane kwa white, but it will be very visible on the other side. Rate of nitrogen, remember, was volume over T. So what are we looking for? What was the question? The question is saying, how long will it take? That means you are looking for what? Time. So we have the volume, we have the rate, the rate. That is our rate. So palio iko unaweka 3.24 centimeters cube. There is a reason why I normally insist is equal to, what was the volume now that we have been given? 150. 150 centimeters cube over t. Because we are looking for time. Remember, we are looking for time. How long it will take? How long will it take you to come from this place to this place? That one. Of course, if you cross multiply, you'll find that t now is equal to 150 centimeters cube over 3.24 centimeters cube. There is a reason I'm writing everything so that you see per second. So E na E inaenda. The time now will remain. What are the units of time? We have mentioned that one all through. It is seconds. So let me do that one. Let me solve that one also. 150 divided by 3.24, you get 46. So mine is 46 points. So remember tulikata vitu mingi hapo we have changed, so tulitoa, we removed some letters here, we have removed some other things that could be divisible there, so we are getting, and because I was using the phone calculator, 46.2 sorry 29. I just think we are getting the same answer, 46 and 46. The only problem is because we truncate, you remember tukikata, that is why there is a difference in the decimal places, but the answers remain the same. Gani iko heri, method 1 or method 2? Which one would you choose?
Hey, what is gonna challenge? But
Yes.
I think the first one seems to be easier to me.
Yes, but I wanted people to, it is the same, you can use the same thing, but I wanted to use the two formulas. Mumeona sasa venye formulas zinafanywa. So
Yes.
it is very, yes. So it is very important for you to know, ukitumia time A na A iko juu. That is, if you choose CO2 and CO2 zikuwe juu, ama you choose nitrogen and nitrogen zikuwe juu. But if you are to go for rate, you are interchanging. A iko ikiwa juu kwa rate, kwa mass itakuwa chini A. That one is very important. I just wanted to pass out that one. So you will get the same answer, but I wanted only to understand you to understand. Now, let me wrap this one, then we go to another example. Then you see. Actually, we are through with this subtopic. And I thank God it is not raining. I hope it is raining your places, because yesterday, I thank God I was already in class. It was raining cats and dogs. So, and it almost started raining today, and I was worried. But Mungu amefanya kazi yake, and we are good to go. So let me wrap that one. Can you try a question? Do you think you can try a question? Do you have a calculator?
We have, but mwalimu, can you do the last method then tufanye question if possible?
Yeah, I'm doing another example. No, I'll do another example before I hand over to you mufanye moja. No, I must do another one. No, I want you to understand. I'll do even two, and then you do one for me. We see kama tumeelewa, si ndio?
Yeah, ni sawa.
Yeah. So we have another example here. I don't know. So how long would 200 centimeters of hydrogen chloride take to diffuse through a porous plug? So they'll give you different terms in porous. Don't be worried. Ukisikia plug, port, material, plate, anything. Don't be worried. You just know. So to diffuse through a porous plug, if carbon dioxide takes 200 seconds to diffuse through. Now, This question is what can I say? Inataka mtu afikirie kidogo, but it is very easy. It is very easy. They have given you the volume, but they have not mentioned that they have given you the volume. If you can see the question. So they're saying, how long will it take hydrogen chloride to diffuse through a porous plug if it takes carbon dioxide 200 seconds to diffuse? So they're saying, if it takes the same volume, that is 200 and 200. But now they're saying, we are different gases. Now, nikasema, ndo usolve hii swali, the first thing you're supposed to know is the chemical formula of that gas. So HCl tumekuwa tukimention hydrogen chloride inaandikwa tu kama hydrochloric acid, so unaandika carbon dioxide tumefanya hiyo, ndio hii, we have done it severally. So HCl tumesema you had 35 which is for chlorine, they have not written here but it is there, I had mentioned. So hii ni 35.5 or 35.5, sometimes they will say 35 depending. So check the question, wakiandika 35 or 36, make sure you have confirmed what you are doing, because the one will give a different answer. Plus one, hii ni one, hydrogen inakuanga number one all through. Wakiuliza hydrogen unasema ni number one, wewe jua tu ni number one, so it is one. So it has so it is 36 point. That is where we are getting the 36.5. Now, so the time of CO2, time of HCl over the time of HCl is equal to the molar mass of CO2 over the molar mass of HCl. Ona tena venye iko HCl iko chini na HCl iko chini hapa, CO2 iko juu na CO2 iko juu on the other side. Remember, when you are talking about the time, the volumes must be what? The volume must be equal. So you can change the volume, but for this one, they have said it is 200 millimeters of HCl, and then we have carbon dioxide, again it is 200 centimeters cube. So inaturahisishia kazi wakisema if it takes that as amount at the same time, so inakuwa rahisi. So that is now you replace. So it is time for HCl ni 200, so inakuwa 200 which is here over the time of HCl which is equal to, now nimesema ukiona hii this one inaweza kaa hivi, let me just show you, it can cut all through because it is the square root at the upper part and the square root, it is called the denominator and the numerator, so it is the square root in both of them. So unaweza weka hivi, usijistress kuweka nusu nusu, but if it will confuse your mind, weka nusu nusu, iko sawa? So you'll have now 200 over times 4 HCl, which now in our case is B, is equivalent. So nimesema what you can do is you can do this, the square root of 44, 44 zote zikuwe ndani ya square root over 365.5, alafu hiyo ndio iko rahisi, you can divide this one, you divide 44 by 36, so una divide tu upate answer and then you square root the answer, it becomes quite easier, yeah. Or you can do what has been done here, which I don't know now, that will depend on you, but let us try mine so that we see if it is coming up with the same answer. So we say 44 divided by 36.5 inakuwa 1.205, and then scientific calculator very quickly, square root answer. So you know this one has a problem. Now when you use the phone, I have to 1.2 something, huh? So when you use the phone, that's why we don't advise students to use the phone, or we don't even advise people to use the phone, eh? So it is 44 divided by 36.5, which is 1.205, and then I square root 1.2, sorry, answer, and then I square root 1.205, I get 1. So the answer after the square root easy, divide and square root, so it will be 200 is equal to 1.097 0.097 over 1. Sorry, this one is over 1. Yeah. So let me change the color very quickly so that I can do it here. So it becomes now 200. Utapata 200 over time for HCl. I want to do this one again, so very slowly so that people can understand, is equal to 1.097. Remember, any number that is a whole number can be over, where you are turning over 1. Yeah, over 1. So then I cross multiply hour, and I'll multiply in hour. So you'll find the time for HCl. I'm summarizing it so that we move a little bit faster. Is equal to 200 over 1.0. I'm doing something different from what has been answered there. And then we see we are getting almost the same answer. The difference in the answer could be brought in by the rounding off, cutting of the, but it will be, you'll still score the mark. So let me do mine. So I'll do now 200 divided by 1.097. And I'm getting 182. If you have done 182.315, let us say 182.32. So 182. And I'm saying the answer, the difference in the answer should be in the decimals. It should not be in the bigger number, like 185. Yeah, that's what I'm saying. You should not get 185. You're supposed to get a difference in the decimals because maybe you will cut. So mine is, I'm saying it is 182, and I've rounded off some, nimekata zingine 182, okay, 0.315 seconds. How is it now? Do you think you can solve a question before I continue? Can you solve? Do you think you can try a question?
I can try.
Yeah, let me give you one. I'm gonna give you this question as this. Let me wrap this one. Nimechafua sana. So I'm giving you the next question. You try. We see kama tumeelewa. Now you can choose the method to use. Now I'm not limiting people. I'm not saying we. I will not say we choose the. We use this formula because tumepeana formula mean. You choose the formula that you want to use as long as you are getting math. Tufike Singapore. Yes, it's now saying Singapore is no longer Canaan. Let me say Tufike Singapore or Tufike Canaan whatsoever. Uh-huh. So let me change mine before I give you your chance. Uh-huh. Now, I'll be taking water. Let me drink water. I think I'm overwhelmed. Ah, I want to give you this question, but it's very interesting. Yeah, this question. I'll give you the oxygen gas takes 250. Let us solve that one. Takes 250 seconds to diffuse through a porous diaphragm. I'll clear the molar. So this one is a different one. They're saying I can clear the molar mass, which takes 227 for equal volume. So it is 227 seconds for equal volume to gas to diffuse through the same porous. I'll give you oxygen. I'll write for you. O is equal to, so O, now pair hapa juu hata. O is equal to 16. But we are already be given, hata ndio hii, that I've circled, but I'll still give you O is equal to 16. Just try that one. Let me drink water and then I'll be back. I'm giving you, so is equal to 16. So they're saying calculate that. So we are looking now, we are changing the question. You are no longer looking for the time it takes. You are no longer looking for the rate. You are looking for the RAM or the RMM. Yes. So you can try that one. Let me get water and then I'll be back. I'll mute. but I'll still be having my pods on if you want to say something. So since we are only two, I don't know if we can wait for each other or we just I don't know if Charity can. If she can, if she's able to at the moment, or if she's held up, we can just continue. Can you? Charity, you can also do the chat very quickly so that we continue. So that we see another example. I think that could be the last example. Then I tell you something small that is not in I don't know if it will be tested in chemistry so far, but it is better to be safe than sorry. That is what I always say. So I think I'll tell you something small. So I'll do this example that you have done, which I think Monica has given me the answer, which is 29 grams. So we fit together, alafu tuone. So because Charity has not said anything, I think I can continue in the meantime. So let me wrap fast and then I proceed. So nilisema, these are now the questions that guided us. We are changing the formula a little bit, but remember the formula. So it's saying calculate. So oxygen text. So we have the time. So we have Ta, which is T oxygen. Let me just write or let me just use what I've been given. There's no problem because we are moving with time. So we'll have T oxygen over Tz, which we do not know, is equivalent to the molar mass of oxygen, is equal to the square root of molar mass of oxygen. Remember, tukiongelea time, I'm still going to repeat that one. When you're talking about time, we are choosing oxygen on top, alafu pia oxygen iko juu, always. And we have T now. The gas which we do not know, we are assuming that it is, okay, we have been given that it is gas Z. So we are saying Tz for the gas now. Time for Z to diffuse over the molar mass of Z. So it is 250. We have been given 227 is equal to the square root of 32 over the square root of Z, which we do not know as at that time, but we are looking for it. So that is the good thing. So you are getting now. The answer here is becoming the molar mass of Z square root is equal to 227. I don't know. I think let me just feed mine to check. And then you can tell us also what happened to yours if it is different. The difference is very small. Divide by is it 250? So we cross multiply. So 227. Let's say 227 divided by 250, which is 0.98. 0.9. Then I do multiplication, square root of 32. And then I square. I don't know if we can square. So the answer is, actually the answer is 263828. Now, Monica, I want you to tell me, because you represent most of us, what happened? 29.
Instead of okay, I use the same formula vile tu hapo umefanya, but sasa hapa
Yes,
kwa
yes, yes.
kusquare root 32 ndio nilisahau
Uh-huh.
kusquare root, so instead nika cross multiply tu directly nikapata 29 instead of 26.
Yes.
I did not
Those
find
ones
square root.
those ones are some of the most dangerous mistakes that we make, especially when we're in a hurry. So inaletanga shida mbaya sana. Now, because of that mistake, can I give you another one to try so that we see if you could correct yours?
Yeah,
Is
okay,
that
sawa.
okay?
Okay.
Now let me check one. Yeah, you see now what I was talking about. Let us do question revision exercise. Or we do question number 4. Acha tufanye number 4. 25 centimeters of carbon 2 oxide diffuses across the porous plate in 25 seconds. How long will it take 75 centimeters cube of carbon dioxide to diffuse across the same plate under the same conditions? So let us do this question. Question number 4. Let me just give you a few minutes also. And then I go to something, and then I think we can end it there for today. I know it is a Monday, but let us do that one. And then I do one. I can do another one, and then we end it there before. But I'll give you some information about what we call the pressure law. A little bit, very small portion. Monica, are you faring more? Do you still need some time or
Yeah, just 1 minute. I'm almost giving you the answer.
Okay, okay. No problem. No problem. Just complete it. So let us check on this. So Monica, you got 28 seconds. I think we solved this one, all of us together, but you know the answer, which is 28 seconds. So 25 centimeters of carbon dioxide diffuses across the polar split in 25 seconds. How long will it take 75 centimeters cube? So nilisema when you're talking about time, when you talk about time, we must make sure that now there's a condition for using time. When you talk about time, you must always, it is a must that you use the equal volumes. So I'm going to do, let us solve this one together. So we have your answer, but remember, for time, I don't know, let me just give you that one first before even I come to this. There was an example that we did in the beginning when we started this one. Uh, the volume must be equal for the formula time. So we must always use equal volume. So I want you to see these ones equal volume. So let me now come back to solving this one. So we have CO. Remember, we should also know for us to get the RMS, or the relative molecular mass of compounds, of molecules, of elements, of what else? What else? Radicals. You must always know their chemical formula. So, so this one is carbon dioxide. So inaandikwanga kama CO. I'm going to solve that one. So RMM for this one, RMM, sorry, so RMM for CO ni 12 plus, that one is from carbon 12 that have been given here plus 16. Inakuwa RMM ni ngapi? 28. So RMM CO ni 28. Now that one is the first one. Now we go to the next one, which I want us to get the RMM. Let us just do the RMM for both of them. So RMM for CO2 has been done several. Let me not even do it again. RMM CO2 tumefanya sana, which I'm saying it is 12. Let me just do it. 12 plus 16 plus another 16. Because now the oxygens are changing to 2. So equal sawa. So RMM yeah, unit 44, which you already know. But after we are done with that one, we go now the formula. So the formula is TCO, for example, over TCO2 is equivalent to the square root. Let me combine the square roots of RMM CO over RMM, sorry, RMM CO2. So pali hiyo iko now. First of all, for this condition, for this formula, we have a condition. So the volume, yeah, time should be equal to the volume here. The volume for diffusion in that particular time of CO2 should be equal to the volume. So tunakuja tu tuna equate. So I want to do their volume with a different color because hapo imejaa. So I go back to blue and then I continue here. So we say 25 centimeters cube in a take. It takes 25 seconds. 25 seconds. What about 75? No. Now, what about 75 centimeters cube? Itachukua how many seconds? Itachukua how many seconds? So, and then you do the cross multiplication. Easy. Now we. So this one becomes very easy. Actually, this is very easy because it is 25. I don't know if you are seeing something that is the same. So it's like saying 25 seconds multiplied by 75 centimeters cube. This one was very easy, over 25 centimeters cube. So E centimeters and centimeters, they go, and then 25 go. So the remaining will be, it will take 75 seconds. So it is 75 seconds. So 75 centimeters cube. So 75. Now remember, we are talking about your CO. So the time CO hapa unakuja una replace now. So we continue. So we have time for CO is 75. So you put 75 seconds. I hope you've understood how I've done that one. Monica, have you understood how I've solved that one? Because they solved mbio kidogo.
Yes, nimeelewa mwalimu.
Okay. And then over E, I learned this class earlier today. CO2 awful, yeah? CO2 is equal to the square root of 28. Remember yenye iko juu ni ya CO. So ni 28 over 44. Now, this one was quite easy. So let me solve using now my formula, which I normally say 28 divided by 44, which is 0.63 recurring. I think it is recurring. Let me check. 0.63 63. So the answer actually is the same. So the time. So let me continue now. I want to wrap this place because this one we're using only to get so I continue. 75. So we have 75 seconds over TCO2. I will check from my phone also again. Whatever I've written is equivalent to. Now let me check. A little bit. 0.7 and 0. Juu yangu nimefanya tu 0.79. I think 7976. 7977. Let me just round off 77 over 1. Remember nilisema any number, for example, you can say you have a million over 1 is a million. A trillion over 1 is a trillion. So it doesn't change, it doesn't affect it. So you just do it, and then I cross multiply. E9 an hour. So you'll find that the answer of time for CO2, I don't know if I'm answering the question, how long will it take? So we're answering the time only. So they are not adding anything. The CO2 is equivalent to 75 seconds over 0. 0.7977. So I want to check mine if it is making sense. So 70, is it 75 divided by, I paste. So the time for that one will be 90. Now, can you tell me what is the problem with yours? Mine is getting about 94 seconds, which is a lot actually. 94.02 seconds. Can I give you a chance to say something?
Teacher, I understand how you have done it, but kuna point sikuwa nimeelewa, but now sasa ona that place yenye unafaa uequate hiyo time. Umesema the volume must be the same. Sasa hapo
Yes, yes, when you're using the formula at time, the condition is the volume must be equal. So you must convert the volumes. That one is very dangerous. It is very. In fact, mimi naogopanga to solve using time. I'll dread that. That is why you remember when we were doing the first question, nikasema gani ni rahisi. You say this one is easier at time. You see now it can bring problems.
Yes.
Yeah, it can bring a lot of problems. So ukitumia rate, actually, if you use the one for rate, you don't have to change the volume because the rate is not affected. You'll be doing amount with time. So unaona sasa ina issue. So ukibadilisha inakuwa rahisi, but maneno ya time is where it has a problem. Time we must convert it such that we are saying the time it takes 200 centimeters cube is equal to the time, what time will it take the 200 centimeters? Yani unapitisha the same gas because ni ya time. So unajua time, sasa hatuwezi sema, for example, if you are moving from one place to another, you must account for that time. So you are saying nilitoka kwangu nikafika job at this time. Now mtu mwingine akitoka, keeping everything constant, atafika at another time. Unaona?
Yes.
But now the distance should be kept equal. So in this case, you are saying the masses or the mass should be equal. Your volume and mass are normally also related. I think you need another. This one now needs more practice. You see, it needs more practice. Yes, it needs a lot of practice. Do you think you can do another one, or you try it and then you send me the answers? For example, because I have a lot of revision questions here.
Yeah, I think mwalimu just give me nijaribu kufanya then I send you kama itawezekana.
Yeah, please. This one requires that, especially that one that we are using time. That is why that was the first example that I wanted to try, because now it normally brings confusion. It is not only you, and I know even those other students who are going to attend or who are going to do to use the streamed video will also have the same challenge, but it is very interesting. The more you do it, the more you understand. Now, before we end, I wanted to say something about something small about what you call the pressure law. It might not be tested. It could be tested. So these are the revision questions. I think I don't know, I'll truncate them. These are very interesting. But before even I continue, ushaipata KLB?
KLB
Chemist. Yes.
Book 1.
I don't know book 3 now. This one is in book 3.
Yeah, I mean book 3.
Yes.
No, sina mwalimu. I'm just using the easy finders.
The best Made Familiar. Even Made Familiar is good. Top Notch is good.
Made Familiar, I have them. Niko nazo mostly kwa all the subjects, but they are mostly questions.
Yeah, they are mostly questions. No, yeah, yeah, KCSE questions. You can try the questions. Now you go to the topical questions,
Mm.
and then you do. Now we are in gas laws. You can use the gas laws. But I normally advise students normally think. I don't know where this idea came from. Where students don't normally want to try the KLB questions. Actually, the KLB questions are very very good. Like if you there was a boy I was telling last year. He was sitting for an exam last year in Alliance. So he was asking me, we were having the same tuition. Akaniambia anaweza tumia kitabu gani since he was coming from let us say an humble background. So ananiambia mimi si they cannot afford to buy me the normal revision textbooks, the top notch, long one and the rest. Akaniambia mimi naweza pata tu KLB. Nikamwambia just study KLB from form 1. If you have the knowledge or the information that is in KLB book 1, book 2, book 3, book 4, you will score an A automatically. The knowledge that is in KLB is enough. You don't have to go outside, and that is if you can't. But if you can't, the better because you'll be more exposed. But somebody who can use KLB, and I'm talking about all sciences actually.
Yes.
Mtu yeah, biophysics, KLB. If you have
Yeah,
a
but
chance to do, then you're good. Yes, 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 yes.
yeah, I think ni kama hiyo exam huwa inasetiwa from KLB kwa sababu I have one for biology ya book
Yes.
4 and nilikuwa pia nikitumia med familia. I have that med familia, so I was looking the questions, unapata the same questions, exactly the same question ndio imekuwa repeated kwa KCSE.
Yes.
The same
KLB
question
like is everything. Ukishika
Hello?
KLB, you are good to go. Yeah. So okay, if you don't have the Made Familia, Top Notch, the rest, all those revision books, I would advise you to go to the KLB. It is very good. I don't know. I think I have the KLB. I hope I have the KLB in my but if I don't, I think I'll post in the group so that somebody can send the KLB to that group. And then if you use the KLB, you are good to go. That is what I am saying. In all sciences, starting from bio, physics, and chem. Kama hauna hizo vitabu zingi, don't be worried. Just go to the questions that are topical questions in KLB. Ukizishika zote, I told that boy, akizishika KLB book 1 to book 4 is in for an A in all the sciences. In fact, he got an A in all sciences. Show me ana vitabu, so ameamua kukaa tu na KLB, and that is what he did. He just summarized the KLB now into his own notes. I don't know, he was good, he was also bright, but he was worried that watu wengine wanamwambia vitabu. Unajua kuna watu wenye they'll give you names of books wakushtue. Yeah, but I normally say if you can use the KLB, that is for 844 system. The KLB is very good. KLB chemistry, all of them. Now, why don't we end this one today? And then please, I don't know. This book had been sent previously. I think somebody sent the top notch from 3, yeah? I think, do you have the top notch from 3?
Notes ama hiyo book.
So, I think I don't know. Let me look for questions like, you remember I sent here from 4, the full notes. That is from, yeah. Let me look for one for from 3 so that you can also try. Yeah. So I'll look for these all the notes. But in the meantime, I'll send this book. This book now is summarized. So mnaona nilikuwa
Yeah.
na explain a lot of things. Yeah, so it is
Hiyo
summarized. So it means you to, yeah. So sio kama KLB. KLB is a little bit wider. So I explain it deeply. But this one is summarized. So, but I'll share this one because of the questions now. This one has very good questions, a lot of them. So mnaona swali zake ni mzuri.
Yes.
So I'll share. And then at the end of this book, at the end of this subtopic, sorry, not even the book, you'll get some questions. Around 30 questions. That from question 1, the revision exercise.
Yeah.
You just do, you choose any. You can do even odd numbers. Yani uone tu kama unazielewa, and then I'll mark for you, and then I'll also explain a little bit. So I'll still share the book. But I don't advise students who have not read very well, or who are not aware about the gas laws, to use this one when they are reading. I would advise students to use this one when they are doing revision. At least unajua you know your maneno ya rules when you're doing this one. You know the laws, and then you know how to come up with the law itself, how to calculate the law, the formula, ukuja na the formula. Yeah. So I'll advise. So the last thing we can talk about is maybe the pressure law, and then we end there. I can say I'll give a good night after we just know what pressure law is. So we have the Charles law, we have the Boyle's law. Now, pressure law was keeping, no, the Boyle's law we are talking about volume, pressure and volume, yeah. And then we have the Charles law. So I can say the Boyle's law. We'll talk about that one. I'll give you another name, but it is not actually scientific or the correct name. So we have the Boyle's law, which was talking about pressure and volume. And then you come to Charles law, which was talking about volume and temperature. So pressure law now. In pressure law, we want to explain now, tunasema tutoe volume tuweke pressure na temperature peke yake we see. And then we fix the volume of the gas. So it says that amount of volume is keeping the amount of volume constant. Pressure and temperature are directly proportional. So this one actually is normally in physics, but I like top notch because they brought it to this one so that it can take care of all the classes. So it is normally a law that is normally studied in physics. So we have pressure is directly proportional to the remember sasa ile time ingine nilikuwa nasema inverse you put 1 over temperature if it was now that case, but this one is saying it is directly proportional. So I have to explain. So pressure is directly proportional to the temperature is this and that way. But if it was inversely proportional, it would have been pressure is inversely proportional to the. So when it is inverse, you see it is 1 over. When it is directly proportional, it is, you don't add that over. And then when you introduce the constant, for me to introduce the equal sign, which is this one, I must introduce the constant. And then making constant the subject of the formula, you'll find P over T is equal to K. Now, if you have many gases, for example, you have gas A being kept at a certain constant volume, and then the temperature and the pressure are changed, you'll find that P1 over T1 is equal to K. Also, P2 over T2, I will use 2, or you can use A, it doesn't matter. It is okay. Over T2 is equal to another K. So I can equate those ones. Now, if you are worried of being confused, please do not do anything. Wacha tu hivyo, formula iko hivyo. So we'll have P1 over T1 is equal to P2 over T2. That one. And this one now is the pressure formula. Pressure law formula. Now we have the Charles law. Charles law, we'll talk about that one so that we see inakuwa nini. So we have the also the Boyle's law, and then you see. So Boyle's law ilikuwa hivi. P1, I think it is P1 V1, is equal to P2 V2. I'll give you this one as something to go and think. This one is called pressure law. What could this one be? Tunaweza ita nini? And then we have V1 over T1, yeah, is equal to V2 over T2. So this one inversely proportional, directly proportional. So if you think you can forget these things, ukiandika hivi na ikuwa inaenda the same side, yeah, that one is inversely proportional. Ikiwa inaenda different sides, that is, you say V1 over T1. This should be 1, eh? This is 2. Ukienda the different sides, that is, you have a denominator and a numerator. That one is direct. When you do not have those ones, that means they are falling on the same side. That one we say there. No, that one is inverse. But lakini ikikuwa hivi, something over something, that one is directly proportional. So when you do a graph of pressure against temperature, it will be a straight line passing through the origin, because as you increase the temperature, the pressure will be affected directly. So if this one is 10, the temperature will be 10. Ikifika 100, at 100, the temperature will be also very high. That is what I wanted to talk about the pressure law. I think that is all I wanted to say about the pressure law. I will not dwell on it a lot, but remember, if you are given a calculation and it touches the pressure law, the temperature should be calculated in Kelvin. I don't want absolute scale. Tafadhali ukicalculate tumia absolute scale, which is in Kelvin. Do not calculate in degrees Celsius. It's the same goes with the Charles law. Ukicalculate na nini degrees Celsius, tumia Kelvin scale, unless there is a very, very burning question touching on the Graham's law of diffusion, or the Boyle's the pressure law. That one is the summary of the gas laws in Form 3, which is topic 1 in Form 3. So the most important thing is to do more practice on these questions. You should do a lot of questions. The more the questions, the better you get. So unless there is a very burning question or something that I can answer in the next few minutes, the floor is open.
Teacher, me I have no question, but hii pressure law ndio tutaendelea nayo ama because
No, we are not doing examples in pressure law. Like I said, I'll clarify that. Pressure law is not normally tested in chemistry.
Oh.
A lot. In fact, ukienda KLB huwezi pata pressure law. But I normally like teaching students everything, because now I normally teach. It's normally advantage to me because I normally teach physics and chemistry, and in gas laws in physics inafunza paka pressure law. Lakini ya chemistry we normally teach only the two laws, which is the Boyle's and the Charles law, and then we do the combined gas laws.
Okay.
So kwa chem, it is not really very serious.
Okay.
So yes, but if it is tested, remember that to change the temperature to Kelvin, that is only the most important thing. The temperatures, when you're doing calculations, I've been mentioning that when you're doing calculations, the temperatures are always in Kelvin. That is in chemistry. So that one is very important. Unless there's a query. Now, Charity is good. Monica, you're good. And everyone else now will be streaming later on. I hope everyone will be good. If you are not good in any part of these gas laws, all of it actually, starting from the gas laws to the Graham's law, I'll be available all through. You can WhatsApp me, you can text me, I'll reply, I'll give you more feedback on how you're handling the topic. Otherwise, have a very good night. Have a very beautiful week ahead because you're starting the week. And have fun. For those that have not taken supper like me, also have a very nice supper. Bye bye.
Good to mwalimu.
Yeah, okay.